And for solving by substitution, to me, a couple of things when you've got this, and of course you've got a system here. The best thing to do on this one when you're going through and doing substitution, because we're going to look at two options. Because last time we talked about graphing, which, again, that one it was specifically asked for the graphs on that part of it. Section 2 is going to ask you to do substitution, and then we'll do section 3 that's going to ask you to do either elimination with either addition or subtraction. But to me, substitution, you almost want to use this when you have in either one of the two equations, so you have either x equals something or you have y equals something. Because that's the part where substitution is going to work out the best. To me, if you don't have it where you've got x equals or y equals in one of the equations, you're better off to do elimination, which is what we'll do next up, coming into one of the problems. But we'll do 2 or 3 problems like this just to show you what substitution is and how you would want to do it and what they'll do from there. Okay, so for the very first one here, we've got x is equal to 2y minus 7. And then we'll do 2x plus 5y equals 22. And just so we can kind of keep them straight as to which one we're talking about and where we're going, we'll just put E1 and E2 at the end because that way we'll know we're talking about equation 1 or equation 2. Okay, and with substitution, you're basically going to do this. With substitution, all you're going to do is you're going to replace the variable in one equation with the expression from a different equation. And when we talk about replacing it, that's the substitution part. That technically you would substitute the variable in one equation with an expression from a different equation. And then once you do this, you're only going to have one variable left over. So you're going to solve for the remaining variable. And once you get x equals 2 or y equals 3 or whatever variable that you get, then you're going to use that variable and use the first variable to go back and find out what the other variable would be. Okay, so, but the big thing on this one is that you've got one equation that you're going to use that expression that's in that part of the equation that you have, and you're going to replace that in the other equation, and then you're going to solve what little bit of equation you have left. And the big thing is that when you're doing these, and the good thing about the online homework, the way it's set up is they give you a box for x equals and they give you a box for y equals, so that you know you have to get both x and y values. In the past, if you didn't have that, sometimes people would get one answer and then they were happy and then they forgot to get the answer to the second one. Okay, so here's what we'll do. And again, we'll start with this equation. We'll work 2 or 3 out just to make sure we've got it. Is that for this one, you always want to kind of go with, I'm just going to scroll down so we've got everything here. We have x equals 2y minus 7 and then 2x plus 5y equals 22. Okay, and if you're going to do substitution on these, it should be that the first thing you've got here where they ask you to replace this one, that you should already have one that's got x equals or y equals. So for this part of it, from equation 1, you have 2x or 2y minus 7 for x. So you're going to replace, and sometimes just writing out the words makes a little bit of a difference for these. So right underneath that, we're going to just put replace, if I can write out the words here. That when you have x equals something, just take the equals out and put with in there. So you're going to replace x with 2 minus 7. But you're going to do that in equation 2. And sometimes just using that word of actually writing it out, put replace x with 2y minus 7. So in equation 2, we're going to take x out and put 2y minus 7 in its place. And everything else we're going to leave it alone. So taking out the x and replace that x with 2y minus 7. And from there, now you've got one equation with one variable instead of two variables. And now you just solve that like a regular equation. First thing is you would have to do a little distributive property. So you've got 2 times 2 for 4y. 2 times 7 for 14, plus the 5y equals 22. And since the 4 and the 5 are on the same side, go ahead and put those together. So you've got 4 plus 5 for 9y, minus 14 equals 22. Add 14. So 9y would equal 36. Cool. Okay, and then dividing 36 by 9, you get y equals 4. Okay, and once you've got the y equals 4, that's half of what you need. And now you've got to take that to go back and figure out what you're, and again, like we were doing last time when we were graphing the lines, you're looking for an ordered pair answer of that for this one. Instead of graphing lines is we're going to find this without having to graph two lines and figure out where they cross. This one, we're just going to use the math and the algebra to figure out where they cross without actually having to graph them. So once you've got this y value, you also need the x value to go with it. That's the ordered pair. So then you pick any equation that you want to plug it back in. But if you pick the first equation that we used to plug into that had the y equals, sorry, it was x equals 2y minus 7. So pick any of the original two equations you have, and the one that's already got the x or the y separated out by itself, that's going to be the easiest one to go back into, because when you plug it back in, you just have to do a little bit of a small amount of substitution. So where you've got the y equals 4, take out the y and put 4 in its place. Why does it keep doing that? You've got x would equal 8 minus 7, so your x value would be 1. And with the online homework with Alex, you're not going to ask you to do it. Most of the time, if I was doing a problem like this, I'd ask you to put it back as an ordered pair. So you'd have 1, 4. But everything I've seen so far with Alex is they just ask you for the x value and the y value and just plug in those two separate answers and you're good to go. If they were to ask for an ordered pair answer, just put your x first and your y. Okay, so no matter what they do, then again with substitution, I would say the best case to go is you have x equals or y equals, it's the best case to use substitution. Let me show you one where they don't do this, and we'll kind of walk to get through this one. And once we do this one with substitution, we'll come back to it for elimination and show you how we would do it with elimination and see if you would like to do it that way. So let's go with x minus 3y equals negative 11 and negative 3x plus 4y equals 13. Okay, so the difference on this one is you don't have x or y by itself, but you can take equation 1 because it has an x by itself, it's just x there. All we've got to do is just get the x by itself, so if we take equation 1 and rewrite it, then one small step will get us there. So if you've got x minus 3y equals 11, you can just add the 3y to both sides. So you've got x would equal 3y minus 11. Okay, so you could take it, in that case, you've got the x that's there, just have to add the 3y over, and now you've got it, so then you can take that and then have equation 2 still be just like it normally is. Negative 3x plus 4y equals 13. So just take the first equation that's got x by itself, or in some cases y. What do you want to mean where we get y by itself? And get that variable by itself. And once you do that, now it's set up so that you can actually do the substitution. So you're going to replace x with 3y minus 11. And again, we'll do that in equation 2. So whatever equation you pull that out of, you got to plug it into the other equation. Okay, so equation 2, we've got negative 3. And again, we're going to take x and replace it with 3y minus 11. And we got plus 4y equals 13. Okay. And same setup as last time. Once you plug it back in, it's just a little bit of distributive property to work through it. So you got negative 3 times 3, that's a negative 9y. Negative 3 times negative 11, that's a positive 33. Plus the 4y equals 13. And because you have the same variable on the same side, go ahead and do negative 9 plus 4. That would make it a negative 5y. Plus 33 equals 13. Run out of room here at the bottom, so for this one we would subtract 33. We got negative 5y equals negative 20. Divide those two and you get y equals 4. Okay, and again, it doesn't matter which equation you plug it into, but the easiest equation you would have is the equation you use to take and plug it back in. So since we took this out of equation 1, we'll plug this back into equation 1. let's plug that back into x equals 3y minus 11. Now, and again, somebody was saying, well, we didn't use the original. Well, all we did for the original was we just moved this 3y over, so technically it's the original. We just screwed that one number over. If you want to go back to the actual original, you could go back to here. But if we leave it like this, it's going to actually make it a little bit easier, because when you plug in the 4, x would equal 3 times 4 minus 11. Well, that's 12 minus 11, so that's just x equals 1. Okay. So if you just, and again, if you want to just tweak the original just a little bit, because again, all we did with the original problem was we just moved the 11 over, or moved the 3y over. If that's all you've done, then that's really the easy thing to do, to kind of go back and plug it back in. Okay, and that's pretty much the only two options you get with substitution. Either you've got one where you've got x equals, or you've got y equals, or you've got one that you've got to just very slightly rearrange it by just, in this case, just adding or subtracting away an x or a y value. Okay, we'll give you one more of those, and then we'll show you what we'll do with the substitution, with elimination. Okay, so there's our two equations. And again, if they're asking you to do substitution, you want to find the variable that's got pretty much there by itself. In that case, this would be the y. Because this one you've got 3x, this one you've got 2y, this one you've got 2x. So when you're doing substitution, you always want to have the one that's got a coefficient of 1, because you got the understood 1y there. That's the one you want to get by itself. So for this one, we'll just add 2x to both sides. So if we do that, we've got y would equal 2x plus 13. Again, all we're doing is just taking equation 2 and just going to rewrite it. Okay. Again, the only reason we did that was that the y was by itself. So if we get the y by itself, then that way it makes it a little bit easier there. All right, and this came out of equation 2. So now we're going to replace y with 2x plus 13. This came out of equation 2, so we're going to do that in equation 1. So we had 3x minus 2y equals negative 22 for equation 1. So we're going to take y and replace it with the 2x plus 13. Okay, and again, just going with a different variable. The first two we're replacing x. This one we're replacing y, but it's still the same setup. On this one, just be a little bit careful because it is negative 2 times x. It'll be a negative 4x, and it's also negative 2 times 13, so it'll make it a negative 26. X is okay, and we got the negative 22. Okay. And again, you've got these two together, so you go ahead and do 3 minus 4, make that negative 1x, or just negative x. Minus 26 equals negative 22. Add the 26. You got negative 1x equals 4. When you divide by the negative 1, you got x is negative 4. Okay. And again, the good thing is you've got the two blanks, one for x equals, one for y equals. So same thing here. Now you got to plug this in. And the easiest place to plug it into is the part you did the substitution with back here, where you had the y equals 2x plus 13. That's the one that you want to use to plug it back in, because it makes the least amount of work there. Plug it in to negative 4. Times negative 4 would be negative 8 plus 13, so y would equal 5. Okay. And there's the two different values that you're looking for. Okay, so when they're asking you to do substitution, that is pretty much it. You're going to have either x equals or y equals by itself. The worst case scenario for those problems is that you may have one where, you know, you've got to either add or subtract away the x or y so that you do have a y or an x by itself. But then from there, it's just replacement, substitution, work out the problem you have to find the first variable, and then use that answer to plug it back into any one of the original problems that you want to. Just pick the one that'll give you the least amount of work to help you forget the other variable for what you're looking at there.